How are you?
I'm good. How are you?
I'm well, thank you.
Relaxed for the 4-day weekend, or?
You know, it was good. Just some family time. I announced our games on Saturday,
Oh, nice.
and the boys' game got crazy because it went to overtime.
Oh.
So I was really pushing my voice out in the microphone. I couldn't talk with it that night. I pushed so hard.
Hi, Stola.
Hey.
I did not get ice cream today.
Okay.
Please next you. What happened on Friday?
We went over the homework for Thursday, but we didn't learn anything.
Do you understand? Okay. I was gonna ask you because I don't either. Do you want a donut?
Oh, sure. You're so nice. Oh, thank you.
The frosted strawberry. I don't know what that means. Oh.
It's going pretty good out there.
But it was really easy to drive.
Good.
The roads aren't bad yet.
Good.
So Stola, I went, I did a homework, from Thursday. I didn't get to complete all the homework,
Okay.
that we had on Friday, but don't I get to
Like that.
Except my lights won't
Try to do when you get it done.
And then was really confused because I come in tomorrow.
Today is an all review day, so make sure I answer your questions. So I'm hitting everything on L today,
Okay.
which was the review.
Exactly. And then upload. Oh, wait, do you want to see some? Do you want to see that TikTok that I It's with Addie. No, it's the same. Oh, really? Like he kept sticking his hand in my shirt and the realized this was very funny to me. This was good.
I like it.
My grandma got it from Spencer's. So upload this 7.
I love that.
And then
I like that. I need
Yeah.
Did you put it yourself? It's gonna be on your desk.
So, I was talking to Emma, and we were talking about Mark Small, and I was like, she is just the sweetest person ever. I fucking love his mom. And so, she goes, does she have any brothers? I was like, nope, just him. Because, like, so when we hung out on Sunday, we went to like somebody that box to get a movie, but they didn't have a movie, so we went to walk. And she goes, oh shit, I forgot to ask you, what kind of snacks and shit do you like? And I was like, what the fuck? And she was just super sweet. And like, she's really funny now. Just telling Emmy this. And she goes, you know what? When you go shopping for your prom dress, you should invite her to come with you. To go pick it up. She's like, I think she would have a blast, and it would just be great. I was like, oh my god, like that sounds amazing. Yeah.
Right where I come down, I was like, just keep your head down, like go around, go around. It felt so weird. Why are you not no, it's not that. It's just looking by teachers talking as slow as hers and like I just wanted to with your backpack. Hey! Well, I want to know
Oh my god.
okay, I posted my TikTok. Why did you do that? It was very hard. Like, it wasn't like good, but you walked, so when I walked, I walked. You know what your TikTok I made?
Can you keep the secrets? Like legit.
It'd be snowy outside.
Literally, Julia can't even do it.
Hey Jacob!
That's literally
Good morning.
It's not in the morning.
Somewhere in the middle of this.
That is very good point, Jacob. I have to give it to you. And now it's like, I saw this. Hey girl! Hey!
So, I played games recently. Started a game in 7th period and finished in 7th period. 2 years. The virus called.
Yeah, I think so. Hannah. Okay, good.
I just want to sit up here because I have so many questions about the homework.
Okay, sit up here.
But Megan's here.
I asked my teacher, I was like, hey,
Maybe if she doesn't come. Someone sits there, right? Yeah, Nancy. No one sits there. What about like right there? Yeah.
No. Megs. Megs usually gets here before me.
Yeah, wasn't she in your Spanish though today?
Yeah, she's here, but
Had like 2,000.
This just came on my phone.
Give me the eggs.
Oh, you know here.
Is that right?
Extra.
And then
Extra.
this is really
I know it smells weird, right? I have like a lot of questions. So if Megan's not here, can I sit up here?
oh, Megan is here.
Megan
Here,
is
how about you sit right here?
really well. Thank you so much.
I mean, I can leave.
I mean, you can.
I mean, like, that's not an issue.
All right, friends.
Sweatshirt. That smells so good.
So I wasn't here Wednesday and Friday.
Cool.
I love
So I'm trying to catch up on the videos.
Cool.
But I'm not sure if I'm gonna be ready for the test tomorrow.
Give you some more time.
Okay. I'm gonna see how I do.
Cool.
Make
Yeah.
a map of
Just I'll let you gauge your best shot. If you come in tomorrow saying I'm not ready.
Towards the end of the day,
Okay with that.
So I'm coming to take my quiz from last week on Friday because I have to take my Spanish test on
Perfect.
Thursday.
Perfect.
I was for sure how's your weekend?
It was good, you?
It was pretty good.
Sure.
Did you go to the basketball game?
I announced them.
You did?
Yeah.
That was such a good game. I was like,
Didn't I announce loud enough?
Arapahoe one? I don't think
No.
that was,
No, we played Eagle Crest.
wasn't that on
I lost my voice.
Were
I lost my voice because I was announcing it. I pushed out so hard on my
you very
voice.
excited about it?
I was.
So intense. It was like so close, like so exciting.
All right, friends.
Well, at least you have a stress ball. Do you know how bad it hurts? Hannah,
Also,
my
also I
stress
have
ball
to time I told you I think my mom has emailed you or she is going to.
it popped all over my hands, and it like leaked through my fingers.
But just so you know.
But I don't care. You know why? Who cares? You look like Alexa.
My
with
friends,
that
my
face.
goal for today is I want to get through 8L. That was assigned on Friday.
No, they do.
There's going to be some that we're going to cross off, and the reason we're crossing them off is you won't see it on the quiz. But then there's a couple other things I need to go over that I want to make sure you feel comfortable with as far as doing the quiz. Does that sound like a plan?
Yeah.
So the quiz will be tomorrow. And coming out to you is some old homework, so grab yours, pass on the rest, please. Okay, so what kind of question? So first off,
L.
worksheet 8L. I'm going to tell you the ones that we're going to cross off. Don't worry about doing because they will not be on the quiz. So don't ask about these, okay?
Oh, perfect.
Don't ask about any of those because I will not quiz you on it. So that's off of 8L, okay?
But 13, 14, and 15 are the easiest ones.
Well, we don't have any that are restricted like that way.
19, 20, 23.
Okay, so what do you want to say? Go ahead.
29.
29, here we go.
Wait, now I have a question. So 20, 19, and 20, there's one that's 21 and it's like exactly the same as those.
Yeah, 20, 21.
Yeah, and
Yeah,
same with,
you'll see one like that on the quiz. I'm happy to work that one out.
but those are like the same as 19 and 20 pretty much.
Right, but the one on the quiz looks very similar to number 21.
Oh, and then the same with 22 and 23. Like you crossed out 23 and 22 is like
22 is a great one. We will definitely work that one out.
Okay, cool.
And I'm sorry, which one did you want to see?
29.
29. All right, number 29. Let's see how we do. Okay, we want to solve this. Now, I will tell you that I think, if my memory serves me correctly, there are going to be 4 questions on the quiz that are going to say, hey, make sure we check for extraneous solutions. I'll tell you that 2 of them have extraneous solutions, and but we'll cross that barrier when we get there. So let's start solving this. Squared, squared. Good so far? Make sense? All right, let's move everything over. So I got 0 equals x squared minus x plus 2. And that becomes x plus 2. Oh, nope. Take it back. X minus 2, sorry. X minus 2, x plus 1. Good so far?
Yeah.
So I find that x equals 2 and x equals negative 1. Okay, yeah.
How did you get -2 and x minus 2 plus 1?
Isn't it
I
2x minus 2x? Isn't it?
There's no solution.
Isn't it negative 2?
Wait. Ask your question one more time.
Wouldn't that make
Are-
like a -2 at the end?
This right here?
Like if you factor it out, it doesn't equal the same.
So let me just do the algebra 1 factor out. So I have a 1 here. 2 times 1 is 2. It's a positive 2, but both signs have to be negative, so the factors of 2 are 1 and 2. So I'm going to have a negative 2 and a positive 1. So I'd have x squared plus 1x minus 2x plus 2. I have an x in common here, so it gives me x plus 1. So minus 2 and then x, minus 1, right? Is that where I made a mistake?
No, it is x minus 2x plus 1. Oh, wait, yeah. No.
No, it works. For some reason I'm off on my factoring. Bless you. Why did I goof up on my factoring?
It's okay.
Should have been x plus 1. So it does factor. So I factored this. Is that where your question is on the factoring?
When you factor that out, doesn't it give you a -2?
So if I multiply this back together, I'm going to get x squared minus 2x plus 1x. Oh, minus 2. You're right. So it doesn't factor, right?
No.
Okay, so you know what I want to do on this one? Let me change it, because if I change this, and I'm going to make that a -2, so I'd make that a positive 2 right there, a positive 2. Is that okay for you?
Okay.
I just want to, and the reason I want to change it is because if I change it, I'm definitely going to come up with an extraneous solution. So does that seem like it works so far?
Yeah.
So that's where my error took place on this factoring gobbledygook. All right, so notice I did make a change on 29. Okay, I changed that sign right there. I made a positive. Okay, so if I take these numbers and I plug it in, 2 plus 2 is 4, square root of 4 is 2. 2 equals 2. So that one works. If I take -1 and plug it in, -1 plus 2 is 1, square root of 1 is 1. Is 1 equal to -1? And in this case, this is called an extraneous solution. So this is my answer. This one isn't. Okay, but please be aware that we changed the sign on it. Okay, and I purposely made that happen so you can see the extraneous solution.
Wait, what do you mean extraneous?
means when I plug it back in, so if I take -1 and plug it back into the original, I get -1 plus 2, which is this, which gives me 1. Is that equal to -1? And the answer is no. That means that this solution is called an extraneous solution.
Because
It doesn't work. Right.
So then why did it work when you solved it?
Oh, because I had the wrong. Oh. It has to do with kind of the imaginary numbers and how they kind of interweave into the math, but we're not seeing it directly.
Okay.
Okay?
So the only answer would be 2, not.
It's just 2. Yeah. So on that one, if you had your answer where you boxed one and then you had one crossed off, I got what you're doing.
Okay.
If you have them both boxed, like, hey, ta-da, you're probably going to miss a point because you missed the extraneous solution. Okay?
So just cross it.
Can I do 25?
Hang on, what do you got?
Can you do 5?
5? Let me do 25 first because I'm on that side, and then I'll get to 5. Cool? 25. Oh. There we go.
Okay.
Okay, so this problem, I get this.
It's chunky.
Divide by -2. Does everyone feel comfortable with the math I've done so far?
Yeah.
Okay, so I'm going to raise both sides to the 4th power. So I get x minus 4, and then 3 times 3 times 3 times 3 is 81. Add 4, so I get 85. Okay, that seems like a nice solution. Let's make sure it works. Yeah.
Where did we put the -2?
You.
Oh, I divided it here.
Oh, because it's icy.
Is that right? All right, so let's make sure that 85 works. 85 minus 4, 81. 4 through to 81 is 3 times -2. -2 times 3 plus 6, so that's -6 plus 6. That is indeed equal to 0, so that solution does work. Like what? 5. Right?
Yep. Yes.
All right. Number 5. G at x over f at x. G at x is equal to x squared minus 1. F at x is equal to 2x squared minus x minus 3. Okay, first thing I'm going to do, I'm just going to focus on the domains of both these. Negative to positive infinity. Domain of this one is also negative to positive infinity. Is that okay so far? So this just tells me I don't have restricted things going into the math that I'm going to do in a sec. So then I have x squared minus 1 over 2x squared minus x minus 3. Does it smell smoky in here?
Yeah, it sure does.
It does actually.
Did you guys light someone on fire again?
Jacob.
Maybe.
Okay. All right.
With the shank.
So I want to factor that bottom part. Agree?
Why don't you just take off that?
I can't cancel
All right.
just like that. I have to factor. So I get 2x and x, and I get minus 3 and plus 1. Did I factor that right? Bless you.
I forget how to factor.
Yeah,
Not gonna
how
lie.
did you get that? Can you explain that?
Okay. So I get -6 if I multiply this times this. Agree so far?
Sure.
So I have positive negative component. Agree?
Okay.
So I get 2x squared. I have to figure out what factors would add to 1. So 3 and 2 would work.
Oh, okay.
And then I have -3, positive 2. So I get minus 3x plus 2x minus 3. Of course, if you combine those back together, you get that. I have an x and a 2x minus 3. And I factor a 1 out, and I get 2x minus 3. So I have 2x minus 3 the same. X plus 1 left over. That's the other binomial.
What?
Okay, wouldn't you factor the top then?
I could factor the top, that's fine, but there's no reason to. Even if I find a 0 up top, there's no reason to factor it out at this time.
Well, then if you factor it, wouldn't it be
x minus 1, x plus 1, then you could cancel the x.
Yeah, but you know what that forms? So this graph, if we graphed it, has something called an asymptote, but it also has something called a hole. And a hole means the graph. So an asymptote will shoot up like that, where you go along something. A hole does this, where it keeps going the same. So because I can factor an x plus 1 out of top and bottom, at -1, comma something, there's going to be a hole, meaning like my graph does not exist there. But I'm not worried about the holes right now. That's like so 2 chapters from now.
We're going to do that.
Yeah. But now I'm just worried about where the denominator is 0.
Okay, got it.
Okay, so does everyone agree that f of x original had unrestricted? Okay, but this at 3/2 and at -1, we don't, I can't plug those in because it makes the bottom 0. But everything else works. So I'm going to go from, my domain for this now is -infinity to -1, -1 to 3/2, from 3/2 to infinity. All this big domain like this means is everything works except for -1 and 3/2. But unfortunately, that's our notation for it. Okay.
Okay.
So that's the answer to this problem. Yeah.
When you get a so you could start off with a
Unrestricted domain?
yeah.
Yes.
And then we get a restricted domain.
Because it became a denominator. And that means those values when I plug into the denominator, those answers, 3/2 and -1, gives me a 0 in the denominator, which makes an undefined term.
And it just depends on the denominator.
Yeah, I'm not worried about the numerator at this time. Scratch everything I talked about a hole taking place on this problem, or an asymptote.
So then how would you do it, like, on number 6 when it's minus? How would you figure out the domain when there's nothing in the denominator?
So you don't have a denominator. So g at x, if you look at g at x, that's unrestricted. J at x is also unrestricted. You just subtract those terms from each other and it still stays unrestricted. You don't create a denominator. You don't create a radical.
So then what would be restricted on here?
Nothing. The ones that are restricted just originally are square root 9x plus 9.
Mm-hmm.
That would go from -1 to infinity.
Yeah.
And q at x, which is square root of x, which goes from 0 to infinity, square bracket.
So how do you know which is restricted and non-restricted?
If I have a square root, if I have a variable or variables underneath, or if I have a square root underneath. Those are the only restrictions we're worried about right now. I'm sure there's many others, but we're not going to focus on them.
Then why is QX restricted when it equals 1?
Q at x is equal to x to 1/2, yes?
Yeah.
That's the same thing as this, which means I can go from 0 to infinity.
Okay.
Stuart.
Yeah.
Are we allowed to use Desmond's tomorrow?
No, 4-function calculator's it. But don't worry, God, trust me. Trust me. Talk to me and...
Desmond's is so much easier.
Oh, I know. Can't use photo math either.
What?
You're like, dude, are you kidding?
I'm like,
When did this rule come in?
Can I say? Wait, we haven't been able to for the whole year.
No, he's just
On
Josh.
a test, we haven't been able to use photo math. Maybe you're pushing back on me. All right, is there anything else you would like to see off of worksheet L? And again, the 13, 14, 15. I'm going to do number 22 if that's okay.
I'll accept it.
yes, please.
All right, 22.
Do we have a lesson today?
No. Well, the lesson is I'm going to go over a couple of just graphing ones real quick just to make sure they're fresh with you.
Off of here.
Uh-huh.
Yes, thank you.
Okay, so they gave us this problem. They've told us we have a restricted domain off the bat. Agreed? So if I want to find by range, I'm going to take negative 3 and plug it in, so I get 6 minus 2 times negative 3. So that gives me 12. And then I'm going to take 3, plug it in. So my range goes from 0 to 12. So all I did is I just plugged in these values. This is an x value, this is an x value. I plugged those in. That gave me the restricted domain now. Agree?
Yes.
Okay, so what is the range of f at x? Well, that's my range. Hey!
Is that an A or a 2?
That's letter A. Given range. Cool, thank you. So the range of f at x is to plug those in to restrict. Okay? Now, letter B, what is the domain of this? Well, that's the inverse. Okay? I don't care what the inverse function is. I mean, I guess we could find the inverse function by saying, okay, I got y equals 6 minus 2x, x equals 6 minus 2y, x minus 6 equals negative 2y. So x minus 6 divided by negative 2 equals y. That's my inverse, which is great. But this here, this domain here, and this range here are the only things that are going to go into play on this problem. Because I might have a number in the denominator, that's not going to make a 0 happen. So my domain of my inverse is 0 to 12. What was 0 to 12 on the original?
The range.
The range. Okay, and then letter C says, hey, what is the range of the inverse? Well, it was the domain of the original. Done. You will see that type of problem. Just almost exactly like that. Yeah.
So for 23, I know you said that's not to look at that one, but for E, how it says like f of 5, and then
Wait, so what's
So the answer is just 5. So if I have an inverse and I plug the original in the original I plugged 5 in, that means I'm just going to get 5 out. If I had,
okay, so for f it's x, the answer is x.
yes.
Okay, thank you.
But like
If it was smiley face, it'd be smiley face
Yeah,
for the answer.
Okay, is that going to be on test?
You might see one kind of like that, but it's not exactly.
Okay, cool.
Wait, so what's the actual answer?
Okay, so the answer to A is here.
Oh, there's different.
The answer to
Oh.
B is here. The answer
I
to C is here. And my
Why?
inverse is here.
So for letter C, why is it just the same thing? Because it's already like.
Okay, so when it's restricted and nothing, so if you look at my inverse, x minus 6 over negative 2,
Yes.
that is not restricted at all. So this inverse here,
What does restricted mean?
well, meaning like I could have a denominator, that would become 0. So there's nothing I can plug in for x to make my bottom denominator 0.
Oh, nothing. You can make that to 0.
Right, there's not an x down there.
Restricted means that if you're looking at a graph, only one part. It's only like a restricted part.
So
of the graph.
this means this can go infinity.
Right.
Unrestricted
But-
means it has
But
to go back.
they restricted it for us
Yeah.
here because they gave us the original domain. Oh, look green. And then we had to find the range by plugging those values in. We plug those values into the original to get my range. And then the range becomes the domain of the inverse.
Oh, because it's inverse.
And then the range is the domain of the original. They just flip-flop.
Okay. I guess that makes sense.
Can you do some more on like the back, like 20?
Yeah, let me do 21 and then I'll go to the
Wait,
back.
can you leave?
Sorry.
That's okay.
You just go.
Oh no.
I think it's
Something's wrong with it.
It's
Yeah.
lost. How am I going to know?
all right. So you're done writing it down. I'm going to recalibrate it. We're going to play the game.
Oh, can I do it?
Can I do it,
And
please?
also,
Please, I'd
hey,
love to
I
do
just
that,
called it
please.
because I asked for it back and I don't know
You
the
ready?
answers. Yeah.
Where do you need me to go?
B, C. This is not the right
Oh.
page.
I'm sorry.
That's okay.
Can I
There?
please
Is that
do
it?
No, that was
No?
the same one you're just done.
Okay.
There's
Let me
no-
recalibrate this.
Okay.
What does recalibrate?
I also couldn't.
Recenters
Where's your
it.
tennis ball? That's how you have to do it.
That looks so fun.
The noise is
What
nice.
is going on?
Oh, nope. Yep, there you go. Okay. So,
Can you do 18?
Let me do the 21 and I'll go back to 18. Cool?
So one like even though like 19 and 20 were
Okay.
one, one like 21 will be.
Yes.
I'm good.
I mean, the skills on 19 or 20 are the same skill. I just wanted to give you one that's more ledge than like one on this quiz. Ready?
I
You know.
like these type of problems.
Do the Anna.
All right.
Do the
Let's
Anna
pretend.
Mahoney. She's 8. I just his birthday today. I just didn't know if you knew.
I want to jail. Oh yeah, it kind of gives me stress.
21.
Oh yeah, no, I don't.
What even is?
What is?
No, Alexis is so
Hey,
bad.
mine is good, you guys.
Okay.
Alexis.
All right. First thing I'm going to
I
do,
don't know if I like.
I'm going to find those points. So I have
I love
negative
it.
6, 1.
Love it.
Negative 6, 1. So negative 6, 1's inverse is 1, negative 6.
Make it so good, but I broke it.
Isn't it just flour?
Yeah, and like oil and like salt.
Feel this one.
Ah.
Alexa, watch your head. This boy's chunky.
Ew. All right. Are we okay so far? Are we okay so far? So the next one, I'm going to look.
so bad.
He reducted it.
So that gives me 2, negative 3.
I like yours better.
Thank you.
Is that okay so far?
Yes.
Is the problem done?
No.
No, we got a few more points to find. Okay, so then I have this point is
Negative 1.
negative 1, 6. Glad you guys have good eyes. Mine are starting to fail on me. So 3, 4, 5, 6, and then negative 1 here. That becomes 6, negative 1.
And then 3, 7 is the next point.
Oh, thank you. 3, 7. So that means 7, 3. So does that. And then
7, 6.
7, 6.
Yeah.
So that means I want to go 6, 7. So it's like there.
Can you maybe never mind, I'll just
6, 7. Okay.
There
So
we go.
that colorful
6,
one,
negative
this is my inverse. Here to here to
So I'm
here
gonna
to here.
fail.
That's my
7,
inverse.
3. There's no. Oh, 7.
It's okay.
3. I'm gonna fail, guys.
Good
You're
thing they
so
offer
smart.
this class every year.
You know what? Nope. Nope.
Riley,
That's
Take my joke.
Shut up.
Yes.
you think you're too funny.
Shut up.
Thursday, Friday, and
It's
Monday.
funny
You
because
have
strokes doesn't
lesson
sound
plans
like.
for
I know, and I'm like,
Thursdays.
Test
It's
tomorrow. That's
actually a
Thursday.
problem.
I think that someone wants to
Friday
take
and
this class
Monday
just
I'll
to
have
fail it
make
again.
sure I record them in the
Yeah.
one line for you.
Cool.
Where are you
Thanks.
going? Yeah,
I'm going to
exactly.
Portland for a dance
I've literally.
Yay.
Everyone's failing. That shows something.
18. Can I move up this one?
And I'm like,
And you sit like
18.
right here too. It's not like it's you.
I'm like,
I don't dance on a
okay, well, I didn't.
partner dance.
Whatever. It's fine.
Okay, so
I wish I had a power.
one, I will tell you that
Retweet.
I will tell you on the test when it asks you to find the inverse and if it exists, they will all exist on the test. If you graph this one, if I graph this one, it would be 3, 5.
18 was confusing.
So it's like that. So I want just this side. Okay? So that means my domain, I'm going to restrict my domain from 3 to
You're
infinity.
supposed to find the inverse.
We will.
Oh.
I'm restricting it first. And then I'm going to find my range. My range is 5 to infinity. Now, if I restrict it, I can find the inverse of no matter what problem I have.
How do you restrict it without graphing it?
Well, I kind of, so you know that your turning point on this problem
It's negative 3.
is 3, 5.
Or 3.
So that's your vertex of your problem.
Oh, got it.
So you could go up based off that, going my x value to infinity, my y value to infinity.
Okay.
That's it. All right, so let's find the inverse. Okay, remember I restricted it? I'm only going to have this be positive. Is that okay so far? Okay? So I'm going to move this here so you can see it. So I'm going to have y minus 3 equals, I could put the positive if I wanted to, no need to. So I'm going to get 3 plus that. This is my inverse. My domain of my inverse is from 5 to infinity. My range is from 3 to infinity. What did I do? I flipped that and that. All right. I want to go on to the graphing thing. So you can either use your separate sheet of paper, or can you pass those around? Coming around is a pink sheet of paper. If you'd like to do it on the pink sheet of paper, it's fine. Or you can do it on your own notes. There's no right or wrong. You make it work. By the time I get done writing these first 5 problems, you should all be able to have a pink sheet of paper.
Wait, now I'm more confused.
Why?
Because of the instructions on this.
Don't worry about the instructions. That's just scrap paper. That was a neat idea I originally had, but there are too many people that take way too long to finish quizzes, so I can't pass back quizzes and go over them.
What a neat idea.
I'm just
Can I
saying.
have a piece of paper? Really?
Oh my god.
No.
It's coming around.
I'm just saying, it has happened quite a few times.
Yeah, I'm just joshing.
Don't be shy. Put some more.
Okay,
Put some more.
so my friends.
Oh boy.
My thoughts exactly.
So, it's coming around. I'm just going to explain. I'm not going to do anything. I know this is coming around. Pass those pink sheets around. I don't know where they're sitting. Someone's got them sitting on their desk.
Oh, that's all.
All right. All right.
I'm sorry, I failed
So-
my job as paper passer.
You're fine. All right. So, all 5 of these problems are a similar type of problem. Yes?
Sure.
Looks like it.
Okay. Now, my friends, there was a skill that you learned in probably even elementary school, if not middle school,
I
which
don't
was
remember anything.
called making a tea table. And then you get to high school, and this is like taboo. Yes? People are like, why would you make a tea table? Because I get the answer right if I do. Don't do that, and then you become frightened because some teachers
I forgot about tea tables.
I hated tea tables.
Oh my god, I remember them. They all just came back to me right now.
Don't worry about the directions on here. That was a neat idea I had at the beginning. You get done?
Yeah.
Cool.
Oh my god.
Is that hard?
You can't answer it now.
Can I leave?
I'm leaving early.
What way?
I have to get 3:45.
Did you tell him?
My mom emailed me.
At when?
3:45. I have to get Lucy.
Can you why? You have to get Lucy.
Because my stuff is with her.
Okay. So for some reason, we've been frightened away from tea tables. So if I'm not letting you use a graphing calculator on this test, let's figure out how we graph these. Rather than looking at it going, I have no idea what this looks like. Okay? So is everyone okay? Is everybody okay that I'm going to put -2 in? Does everyone feel comfortable why I'm putting -2 in?
No, I know.
Why?
I know this one.
Why?
So it makes the x equal
Yeah.
0.
Yeah, if I plug -2 and I get -2 plus 2, 0, square root of 0, 0. Agree?
Yes.
Okay, now, I want to have other perfect squares happen underneath. So if I plug -1 in, -1 plus 2 is 1, square root of 1 is 1. And then if I plug, I guess, maybe even 2 in, 2 plus 2 is 4, square root of 4 is 2. So if I graph these, I get -2, 0, -1, 1, and 2, 2. So it looks like this. So this has a domain that goes from -2 to infinity, a range that goes from 0 to infinity. And that's it.
Is this on
But
your
I used a tea table to make it work. Guess what I didn't memorize? What the graph looks like. Let's see, we're dealing with an infinite number region. It's an infinite amount of graphs. You should know what the graph looks like. Which one?
Yeah, period.
Okay, for some reason,
Here.
we've been frightened away from tea tables because someone thought it was taboo. You're like, don't do that.
Can you explain
No,
what taboo means?
It's okay.
It
Like,
means math.
Not
It's
acceptable.
like that game. Crazy.
Not acceptable.
I read
All right, so let's try the second one. Let's try the second one. I'm plugging 2 in because I'm trying to get the underneath the 0. So square root of 0 is 0. I'm going to plug, I don't know. Could I plug in 1? Nope. I don't want negative numbers down there. So what if I plug in
4.
3? 3 minus 2 is 1. Square root of 1 is 1.
Do 4.
And now I have enough information to really plot this. So 2 comma 0 is here. 3 comma 1 is here. That's what this graph looks like. So this domain goes from 2 to infinity. The range goes from 0 to infinity. Again, did I memorize the graph? No. I know that I can't have a square root of a negative. So that's all I'm really knowing.
Can't you just memorize the parent function and do it from there?
Some can.
No. And my mom said she emailed you.
I think she did. I saw it.
You saw it?
Yeah.
Am I good?
Yeah.
Thank you.
Watch the rest of the
5
video
minutes.
for tonight.
Okay, thank you.
Because it'll on this. It's towards the end.
Okay,
It's
thank you.
important.
All right. So now this one. Think about this one. If I plug in, whatever I plug in, I'm going to have the negative. So if I plug in 2, negative 2 plus 2 is 0. Square root of 0 is 0. Agree?
So do you guess on those numbers or you just know?
Look underneath. Use logic. What makes it 0?
Wow, that's kind of mean.
No, it isn't.
Use logic.
Okay.
Okay? So, I mean, you're just looking what would make the bottom 0. That's all I'm doing. I mean, it's Algebra 1, 3rd week. I'm serious. All right, so now, I want to get this to be a 1 underneath. What do I plug in to make it a 1 underneath?
3. Wait, I have a question.
1.
Sorry.
3 would give me a negative 1. I like your thinking, though.
1.
Is it negative 1? Or if I plug 1 in, negative 1 plus 2 is
1.
1. Square root of 1 is?
1.
I have enough to graph this. So 2, comma 0, 1, comma 1. What did this graph just do?
It flipped.
It did a horizontal flip. So this has a domain that goes from negative infinity to 2 and a range that goes from 0 to infinity. It's still growing up.
This is random.
Okay, and again, I'm using a t-table. I'm using something that we learned in 6th grade. Here's a t-table, and all of a sudden it's like, hey, go through that. You're like, yeah.
Why would you start
Or like go
for
on.
the ones with the negative x's? I'm just confused how. you would
So
do that one.
what I'm trying to do is I want to figure out what I plug in here to make it 0.
Mhm.
'Cause that's going to be my start point.
So then wouldn't it be negative? Or
If I plug in 2 for x, I get negative 2 plus 2. Because that negative in front, no matter what I plug in, it will turn it negative. So negative 2 plus 2 is 0.
okay.
Make sense?
And then the next set of numbers is just whatever.
What do you think? All right, so let's change color a little bit.
Maybe.
Negative 2.
Yeah. Yeah.
So someone said negative 2. If I plug negative 2 in, negative 2 is 2. 2 minus 2 is
0.
0. Square root of 0 is 0. Okay, what do I plug in here
3.
to make it, negative 3? I plug negative 3 in. Negative 3 is 3. 3 minus 2 is 1. Square root of 1 is 1. I have enough information to graph this. So 2 comma 0 is here. Whoop, I made a mistake. I apologize. Negative 2 zeros here. Negative 3 positive 1's here. We good? Like that. Domain. Negative infinity to negative 2. Right? Range. 0 to infinity. Done. Okay, so we had 2 of those that had horizontal flips. And then the last one that we're going to look at is I had the negative outside. Okay, I want the bottom to become 0. What do I plug in to make underneath the radical 0? Yes. Negative 2. Square root of 0 is 0. Negative 0 is just 0. Okay, let's make underneath 1. Plug negative 1 in. Negative 1 plus 2 is 1. Square root of 1 is, I have a negative. So 2 zeros here. Negative 1. Oh, I goofed. Negative 2 zeros here. Negative 2 zeros here. Negative 1 ones here. So here's my graph. So that one did a vertical shift. So my domain, negative 2 to infinity. And it comes from negative infinity to 0. because it's coming up. So those are definite good ones to see. Okay? Can I move off this screen? It is recorded. So, you good?
Can you put like these notes online?
I do every night.
Oh yeah, but like the homework questions and stuff. That's
I do every night.
What?
I have a PDF of everything I write up
I
here.
see all the notes. I never even see the
It's
homework
in the
questions.
notes. The first like 15
Oh,
minutes.
what?
I record bell to bell. I really do.
Oh no, I know. Like I like watch them before.
Okay. Yeah, and then the PDF that goes with it on the same date is the notes.
That is notes.
Yeah.
Nice.
Okay. So
Is that a
I kind of have to know that this will look like this. I kind of have to know that. Okay?
Yep.
Left 2, down 7. So this point right here, I'm going to go left 2, and I'm going to go down 7. So this point moved here. The graph looks the same. So when I'm grading this, I'm looking, did you have this point? And did you have a graph that kind of looked okay? Now I don't want someone, well, I had the point there. Look at my graph. Like, that's the wrong graph. Okay.
Do you want us to restrict it and put the domain?
There's no restriction on this one.
You don't want us to?
Well, I could say that my domain and range are both negative to positive infinity.
But remember, one time you were you need to restrict it if it's unrestricted.
This one doesn't need to be.
How do you know when it needs to be?
A third root won't have a restriction.
Yeah, but didn't you say sometimes on the square root graphs?
The
and
square
stuff?
roots will, but I won't
Oh,
switch.
just because it's not one to one.
And the very last thing, can you give me a minute?
Yeah.
Okay, this is simple. Even, odd, or neither. Still with me?
Yes.
Yes. Okay, so let's say I have this as an equation. F of x is equal to x squared plus 10. Good? If I don't have a graphing calculator and I can't see, this will fold over the y-axis, I'm going to take negative x, plug it in. Negative x times negative x is x squared. If I plug negative x in and I get the exact same thing out, if these match, that means it's an even function. Okay?
Wait.
So why did this work this way? Why did that become now positive? Because I plugged a negative x in, I squared it on negative x times negative x. Because all this means is this, negative x times negative x, that gave me x squared. So it's the same. That means it's even. If I have this, if I take negative x and plug it in, negative x, negative x, negative x still stays negative. Becomes negative 3. 4 times negative x, negative 4x. Are my signs all different?
Yes.
Yeah.
So from here to here, that's different, that's different. That means this becomes an odd function.
It has to be every single sign.
Yes!
Okay.
If it's not, if you have one that, let's say it went plus, plus, plus on top, and down below went minus, minus, plus,
Then it's neither.
neither.
Okay.
Peace out. Have a great day. Take care of one another.
I don't have the packet in the way. Apparently, I have the wrong. I was taking them out of the book and doing them.
Oh.
You too.
Let me make, you have a sec, can I make a copy of this for you?
Sure.
This is my last packet.
Okay.
Is this just,
Homework.
okay, because you won't be here tomorrow.
Yeah.
I kind of understand. And then, so, question. So,
I have like a lot. I have a lot. That's
you have a camera? Just keep getting folders. Take a picture of each page. And then you just write it on a separate sheet of paper.
Yeah. Bye. See you next week. Sorry. sorry. I know what it is.
Yeah.
Oh, and for the okay, so this is my question. And for the graphs, I didn't know that, so I just did them like this.
Do you feel good about them?
I didn't do the
Okay.
points.
No, I think you're good.
Yeah.
I was just trying to show, because you probably see the graphs.
Yeah.
I was just showing the others who aren't seeing the graphs right away. T-table, it's going to work.
Okay. And then this is my question.
So minus 4. Subtract the 4 first. So you get x minus 4 over here.
Oh.
Put that in parentheses and square both sides.
Okay, so it's 16.
Well, x minus 4 quantity squared.
Yeah.
Oh, right. Is it okay if I didn't do like 3 problems?
Yeah, Sapphire. Please tell Sapphire to bring that tomorrow.
I'm not gonna see her anymore.
Oh, you will?
Sorry.
Did you get what you need?
Yes.
Cool.
And then, is it okay? Can I just do like all the evens on all of
That should work.
Okay. Okay.
Yay!
Thank you.
Thank you, Sarah.
You got it. Oh, can you flip the lights on the way out? Thank you much. You too.
Okay, I'm done.
Cool.
Just have to check.
Cool. So where are you going?
Mexico. It's
Oh.
gonna be my brother's bar mitzvah.
Oh, really?
Yeah.
Well, enjoy time with family and friends, okay?
Yeah.
Will you be by the ocean at all?
No, Mexico City.
Oh, Mexico City?
Yeah.
Find me something really unique and take a picture of it for me, would you?
Yeah.
Perfect. Thank you.
And also Andrea's there, so
Oh, she's there?
this year, yeah.
Oh,
She's been there for like 2 weeks.
really? She doing okay?
Yeah. Yeah, she hasn't been in school this semester at all, except for Monday.
Well, let her know I miss her.
Yeah.
Give her a high five for me, would you?
Oh, and I wanted to tell you, I went to Jill Abraham that came here to give
Yeah,
a talk.
yeah.
I went to shadow her yesterday.
Really?
Yeah.
What'd you see?
I emailed her a while ago and she didn't answer, but then she answered like last week. And yeah, I was in the ICU for cardiology.
Really?
So it was really interesting.
Oh my gosh.
Yeah, in the children's.
You're finding your passion.
Yeah.
Love it. Love it. See you soon.
See you next week.
I look forward to it. Enjoy your trip.